When we look up at night, we usually search the distant stars for answers. But there are still profound mysteries hidden right here, in our own solar system. For over half a century, the footprints left in the lunar dust have sat undisturbed. Our efforts to cross the cosmic ocean paused, leaving the moon as a silent monument to a past period of exploration. That pause ends in the year 2028. The Artemis 4 mission is underway. Breaking free of Earth's gravity requires the Space Launch System, a launch vehicle capable of hoisting tens of thousands of pounds of payload into deep space. At the tip of that system sits the Orion spacecraft. Once separated from the launch vehicle, it carries a crew of 4 astronauts on a 4-day silent transit toward lunar orbit. Artemis 4 represents a shift in strategy. Rather than making a brief visit to the surface, the program is designed to build the infrastructure required to live there permanently. Waiting for them in the pitch-black orbital void is a solitary metallic structure, Gateway. Humanity has maintained outposts in low Earth orbit for decades. This is our first space station positioned to orbit an entirely different celestial body. Approaching the station requires a precise sequence of maneuvers. Orion must align its trajectory perfectly with Gateway's polar orbit, matching speed and orientation in the vacuum of space. Orion docks with the European Space Agency's central IHAB module, physically connecting the crew to their new habitat. This immediately establishes a vital network. Oxygen, power, and thermal regulation begin circulating, creating a single, integrated life support system. Gateway transforms the hostile vacuum of space into a secure harbor, a staging ground that makes prolonged survival around the moon possible. Once the station is fully activated, the crew divides. 2 astronauts remain aboard Gateway to monitor orbital operations, while 2 transfer into a specialized landing module to begin their descent. The flat, gray landscapes of the Apollo era serve as a historic baseline for this mission. This crew is targeting a far more complex geography, the lunar South Pole. This alien landscape is defined by massive geographical contrasts. Because of the low angle of the sun, mountain peaks here are bathed in perpetual daylight, while the steep floors of deep craters remain trapped in eternal darkness. Within those freezing, pitch-black craters lies a critical resource. Shielded from solar radiation for billions of years, vast deposits of ancient, primordial water ice have survived intact. The brutal terrain of the South Pole presents intense engineering challenges. However, the presence of that frozen water, which can be split into breathable oxygen and rocket propellant, makes it the most strategic location for human expansion. The astronauts have exactly 1 week on the surface to complete their objectives. Their primary task is clear: navigate into shadowed craters, extract frozen water samples, and prepare them for Earth. Doing so requires operating in some of the coldest microtemperatures ever encountered. The crew must rigorously test a new generation of spacesuits designed specifically to keep them alive in these extremes. This topographical map illustrates how these craters dictate the mission's long-term layout, establishing the exact perimeter for the first permanent lunar base. Astronauts will mark specific coordinates where future habitat modules, rovers, and power grids will be installed. Setting these initial markers into the lunar dust provides the physical foundation for long-term human presence. It is the first step toward turning a survey site into a functioning lunar outpost. At the end of the week, the ascent module's engine ignites, detaching from the lunar dust and thrusting the crew upward into the void. The equipment and footprints they leave behind will not erode. Without an atmosphere to wash them away, they'll remain as they were for millions of years. High above the surface, the ascent module catches up to Gateway, executing a final rendezvous and docking maneuver to transfer the returning astronauts and their ice samples. Reunited, the crew of 4 seals the Orion spacecraft and detaches from the station, firing the main engine to initiate the long, silent trajectory back toward Earth. Their arrival will test the limits of physical engineering. The capsule will slam into Earth's atmosphere at over 40,000 kilometers per hour, generating friction heat that reaches thousands of degrees. Successfully surviving that re-entry provides a necessary proof of concept. We possess the technology to send humans deep into the solar system and safely retrieve them. Artemis 4 secures a human foothold on the moon. Yet the lunar surface is a stepping stone. Every spacesuit tested, every habitat module mapped, and every docking maneuver practiced in lunar orbit is a rehearsal. The technologies being proven right now are the templates for reaching a glowing red planet tens of millions of miles further away. Pushing toward Mars forces us to confront our place within an infinite universe. We are a species born on an isolated, fragile globe. For nearly all of our history, we could only look up from the surface and wonder what was out there. Leaving our home planet to build in the dark of space reflects the same drive that has pushed every human expansion: the need to turn a hostile frontier into a place where we can live and work. Light from the most distant stars travels through an absolute, freezing vacuum for millions of years before it ever reaches our eyes. Across that distance, the universe is mostly cold and silent. For over half a century, the moon has remained silent too. The footprints, rovers, and equipment left behind by the final Apollo explorers have sat undisturbed in the lunar dust since 1972. But the focus of space exploration has changed. The era of the short-term visit is being replaced by a commitment to permanence, a shift from merely reaching a destination to building the infrastructure required to stay there. The 2028 Artemis 4 mission is the definitive turning point in this plan. It is designed to execute 3 specific mechanical steps that will establish humanity's first permanent residence outside of Earth. Breaking Earth's gravity with the heavy components of a space station requires the SLS Block 1B. This upgraded version of the rocket uses a more powerful upper stage to deliver over 84,000 pounds of payload toward the moon. The Orion capsule serves as the orbital tugboat. It grapples the International Habitation Module, or IHAB, and ferries it to the station. Orion maneuvers the IHAB into a precise alignment. Once locked into place, the gateway's habitable volume nearly doubles, providing life support for long-duration stays. This orbital port is a mandatory prerequisite for the mission. It ensures that any crew descending to the surface has a fully stocked, pressurized command center waiting for them in the sky above. While the crew expands the station, another critical piece of hardware will already be in position. A commercial human landing system, launched ahead of the crew, waits silently in a high lunar orbit. The Orion capsule matches speed and orientation with this lander, docking at thousands of miles per hour to create a single integrated vessel. Once pressurized, 2 astronauts physically transition from Orion into the landing module, preparing for the final drop toward the surface. Mastering this mid-space transfer is the engineering bridge for the entire program. It allows NASA to separate the long-haul transit ship from the specialized landing craft, making the logistics of the descent mechanically possible. The lander detaches from the orbital station and begins its long, quiet descent toward the hostile terrain of the lunar South Pole. The terrain here is a heavily cratered landscape, far more rugged than the smooth plains explored by the Apollo missions. This region is defined by geographical extremes. Towering ridges stay in sunlight for nearly 90% of the year, while the floors of nearby craters have sat in total darkness for billions of years. Over the course of a week, astronauts will anchor a permanent base. They'll install foundational power systems and critical communication arrays to support teams living here long term. The primary goal is harvesting the ice hidden in those dark craters to provide oxygen for breathing and hydrogen for rocket fuel. This allows a permanent base to sustain itself without a constant, expensive resupply from Earth. From the isolated vantage point of the South Pole, Earth is a fragile sphere against the total blackness. It is a reminder of how far the species has traveled from its only biological home. Artemis 4 isn't the finish line, it is the proving ground. This mission is where we learn how to keep complex machinery and human bodies functioning in deep space for the long term. The lessons learned in the lunar dust, like mining water for fuel, are the exact capabilities required for the journey to Mars. The moon is the training camp for the rest of the solar system. We are a species that evolved on a protective, temperate world, now attempting to survive in a vacuum that is naturally hostile to life. The effort to build these ships and sustain life in the void is how we find our place in the silence. By establishing this first base, we ensure that when we look out into the dark, we are no longer just observers. we are building the infrastructure that carries us further.